So just a little bit about us. My name is Akansha and I am the VP Events at CSME. And we had a really great time hosting this with R3. And we just wanted to say that CSME, like R3, wanted to give students the opportunity to provide them opportunities they wouldn't get in their regular engineering curriculum. CSME specifically, we want to foster positive relationships within people within the mechanical engineering community. And we tend to host events like our case competition, as well as the formerly known CSWA and CSWP SolidWorks workshops. And if you'd like to connect with us, feel free to send us an email at csme@ryerson.ca or follow us on our social medias. And I think I'll just hand it off to Vanessa.
Thanks, so I'm Vanessa Van Decker. I'm a mechanical lead on Ryerson Rams Robotics and a media and outreach lead. And Moustafa is here with us today, and he's our software controls lead. He's going to tell you a bit about himself in a minute. And Ryerson Rams Robotics is a passionate robotics collective at Ryerson. We compete in multiple competitions. You can see our beloved rover Navi behind me on my virtual background. So for Navi, that's the Utah desert behind me. Compete in the University Rover Challenge every year. And then as well, we have a RoboSub, which is an underwater autonomous drone robot. And it competes in San Diego at the RoboSub, RoboNation, Robo. So we love robots. We do a lot of designing. We're quite a large team. We have about 130 to 140 members currently. And we run the gamut from science education to controls software, controls hardware, so like electrical, mechanical design. And we also have a science team to like do soil analysis, figure out, is there life on Mars? So lots of fun stuff like that. So we hope you enjoy the workshop.
All right, so a bit about me. I'm Moustafa. I'm a controls lead at Ryerson Rams Robotics, and as Vanessa said, I focus mostly on the software. I'm also an electrical engineering at Ryerson, a student at Ryerson University, and a couple of things about me is that I was a research assistant at Ryerson with two different professors working on two different projects. And just as an introduction for this workshop, through my research assistantships, I used Python a lot. So in my first one, which was in the summer, we were working on a implementation for like cryptography. So some like encryption and stuff for say like ATMs and things like that. And we used a language called Rust, but we also used Python. So Python can be used in that area. And also in the fall, I worked as a research assistant with robotics. And the robotics was all those, I worked on simulations. So robotic simulations. So if you have like a robotic arm, I did some simulations for that. And that was also using Python. So Python is very, very widely used for many things. So it's great that you're coming here to learn it, and hopefully you'll come out of this workshop with a new skill. So Python is very easy to learn and use. So most of you here, I think, have done CPS 125, which is C, and C is actually more complicated than Python. It's because it's very low level, so it works best with machines, but it's more you have to basically implement everything yourself, and it's very complicated. But Python it's a much higher level language, meaning it's much easier, and most like in the language, a lot of the stuff that you have to do manually in C is already implemented for you. You just have to use it. That's why it's like very easy to learn. It's also very popular. There's a huge community. I read like a stat in 2019 that there was 8 million users worldwide using Python. So that's actually a very large amount of people, and that shows you that like you can use it a lot in the workspace. And then so it has many uses, so I'll like list some stuff here. So we have computer vision. So we have some libraries in Python called OpenCV, YOLO v3, and Detectron 2. So this is for when computers want to detect objects. So you've probably seen like Teslas have object detection in their software, and you can also do that type of object detection to detect objects using Python. We have also machine learning libraries called like TensorFlow and PyTorch if you want to learn machine learning. And then web development is also possible on Python using Django and Flask. So if you want to create your own website, Django is actually very great. Fun fact, Instagram was first created with Django. So before they switched to a different a tool, and when they came out, they made it in Django. And then data analysis, we have two libraries called Pandas and NumPy. That's all for like data analysis and calculations and like math heavy stuff. And then something we're going to be using today, Tkinter, is for GUI programs. So if you know like your usual programming is like printing to the terminal or to the command line, and you can see everything in the command line. Today we're going to actually make a GUI so you can see it as an actual program. So there's PyQt and there's Tkinter. Today we're going to use Tkinter. So let's talk a bit about Python versus C. So Python, so a couple of things. So I'm going to compare. Python actually doesn't have any variable types, and you're going to see this soon when I go into the code. You'll see what I mean. So in Python, you actually don't need to declare a type for the variable. So if you have a variable like you want to put a number in your code, and like the variable is an integer, you don't have to actually declare that it's an integer. But in C, you have to. If you remember, it's like int number equals something. And I'll show you very soon. So Python has very simple code syntax, versus C has more complicated code syntax because Python is a much higher level language. And then Python is actually slower than C because Python goes through two stages in order to get to run the program. There's the interpreter and then there's the compiler. The interpreter actually, because it's high level, it has all the things that helps you program. It has to go through two stages, which makes it slower, where C is more complicated, but it goes through only one stage to run the program, which is the compiler. And then we have, it's a high level language, and C is a low level language. And then Python is more general purpose programming language. So you can use it for a lot of different things, like I showed in the previous slide. While C is actually more hardware oriented. So in R3, we use C a lot, and Python, but we use C for like all the electronics that we have to code for our robots. So the electronics itself, like the microcontrollers which run the robot, that has to be coded in C because it's very fast and very close to the machine itself or the electronics itself. While Python, so if we have to do any camera stuff, any like networking, any GPS or anything like that, Python is very good for that. We actually use that all the time. And then okay, so yeah, so we have in Python, as you can see, like I showed you here, all these libraries. You're probably wondering, how do I use these libraries or how do I install them? I use something called a package manager, and Python has one installed right away called pip. And in your terminal, you can in your command prompt or terminal, you can just write pip install and one of these names for these languages, and for these libraries, and it'll install it for you, and then you can use those libraries right away. While C, it's much harder. You have to actually create the folders, you have to create the directories, the libraries, and then you have to do it all manually. It's actually much harder for C, and very complicated. So it's very easy to do it in Python, which is the best thing about using Python. So how I use Python every day. So in R3, we use Python all the time. So we have the Raspberry Pis and NVIDIA Jetson are these like mini computers. So you know how you have a computer. The Raspberry Pi is like a very mini version of the computer that we put onto our robots, and it can do a lot of things that we want to be done on the rover, like any camera stuff, any GPS reading, all that, which I said in the second line. So GPS, compass sensor, and autonomous navigation, that can all be run on this like mini PC. And that actually runs Python. And then we have OpenCV we use for like object text and symbol detection. So you can hold up like a paper with some text, and it can actually read it and output that text to you. And like QR codes, for example, we can actually detect that with OpenCV or AR tags, and you can just show it to the camera and it'll detect it. So there's also cameras and image compression. So if anyone like wants to send camera feeds, so on our rover we have cameras and we want to send that camera feed to our laptop, you can actually do some image compression to compress that image to make it very light, and then send it over through the wireless network. All can be done using Python. And then a couple of things for the rover also, like there's a thing called a robot operating system, and it's a way we can program robotics in Python. And it's widely used in industrial robots. So that also uses Python and C. And then we have also robotic arm simulations, like I talked about in my research job, that I actually used Python in order to do some simulations. Okay, so let's go to here. Okay, so how to install Python and start programming. We actually sent a PDF before the lesson to on like how to install Python and VS Code. But this is just a quick overview. You head over to this link, python.org/downloads, and then you can see download Python. I think it's now 3.9.1, or whatever the latest version is currently. Download that, and it should download no matter your operating system. So if you have Mac or Windows, both, it should download the one for your operating system right away. And then VS Code, same thing. I didn't put the link here, but the link is in the PDF that was sent before. You can download that IDE for when we start. Okay, so enough introductions, and let's start programming.